Piecewise functions are functions that are literally defined in pieces. They may need more than one formula to generate the y outputs. So what has to be done is, for each different piece of the formula that's needed, there's a little inequality criterion over here that lets you know which values of x are used with that piece. So for example, this function is defined as f of x equals, and then this squiggly bracket sort of opens up for the different pieces that are used. F of x can be 2x plus 5, so your y outputs will come from 2x plus 5 if your x inputs are less than or equal to 0. Then your f of x will generate y outputs using x minus 3 if the x inputs are greater than 0. So given that these two inequalities are here, the purpose of those inequalities is essentially telling you your input criterion. Okay, if I choose any one value of x, like if I choose x equals -6, that's my x value of input. What you have to do is say, well, x equals -6, that's my x input, that's my x value. Is my x value less than or equal to 0, or is it greater than 0? Well, is it possible for any one number to satisfy both of these inequalities at the same time? Never possible. So -6 is an x input, -6 is less than or equal to 0, which means that only satisfies the first inequality criterion, and that means this is the piece that I would use to generate the output there. If my x values are greater than 0, then I'll use this to generate the output. Okay? So the domain of this function, the x values that are used, well, I'll have some x values that are less than or equal to 0 or greater than 0, but technically those inequalities describe everything on the real line. So your domain is still all real numbers. Part of the domain comes from x being less than or equal to 0, so that's everything up to and including 0. Then everything greater than but not including 0. Notice you can't have overlap there because that will give you two outputs for one input. You got to guarantee that these two inequalities are disjoint sets. So minus infinity up to and including 0, and then parentheses 0 to infinity. Here's these two portions of the domain. That's exactly what those two inequalities describe. So if I bring these two sets together, it's the entire real line. So the domain of this function is all real numbers. It'll take every real number as its input, but you got to just be careful about the way you generate the outputs. So my x input is -6. Which of these two input criteria does it match up with? -6 is less than or equal to 0, so that means f of x, in this case, is going to use 2x plus 5, because my input is something less than or equal to 0. So that means f of -6 will equal 2 times -6, -12, plus 5 is -7. And that generates a point on the graph. A point at -6 for x, -7 for y. So let's do a couple of more inputs for this piecewise function. Here, my x input is 0. So which of these two inequalities does the 0 value of x actually match up with? 0 is less than or equal to itself, or is it strictly greater than itself? And again, any one x input can only satisfy one of those two criteria. X equals 0 is less than or equal to, there's the only time you're going to use the equal to part. So that means it satisfies the first inequality. 0 less than or equal to itself. So once again, we're going to use the formula f of x equals 2x plus 5. If I'm plugging in 0, f of 0 gives me 5. And that generates another point on the graph. A point at x equals 0, y equals 5. We just found the y-intercept of this graph. Okay. So now for x equals 2. x input of 2. Double check the criterion up here. Is 2 less than or equal to 0? No. 2 greater than 0? Yes. So since 2 is greater than 0, that means now for the first time we're going to use the second piece of the function. F of x will generate its y values by using x minus 3. So therefore f of 2 equals 2 minus 3, negative 1. And that puts a point on the graph at x equals 2, y equals negative 1. So whenever you're dealing with inputs and outputs on a piecewise function, this is where you have to look first. Because depending on what your input happens to be, it's going to satisfy only one of those inequalities. And whichever inequality it actually matches up with tells you which piece of the function to use to generate the output there. So under no circumstances ever will you ever use both pieces for the same input. That's not the way a piecewise function works, because that defies the definition of a function. You can't get two outputs for one input. One input, each of these one inputs generated one and only one output based on the correct interpretation of this piecewise formula. So to generate a piecewise function's graph, what's best to do is to actually divide your graph paper at the x value that splits its domain. See, the domain is all real numbers, but 0, x equals 0 was the split point, because part of my domain uses this formula for x less than or equal to 0. The other part of the domain comes from greater than 0 that uses this piece of the formula. So it's best to actually kind of make that a special point for generating the graph. So when you're making a piecewise function's graph, two things you're going to want to use. A straight edge, well, mainly because both pieces here are linear. You know, y equals mx plus b, so we have a slope and a y-intercept, a slope and a y-intercept. So a straight edge will come in handy for that. But you definitely want to use a pencil with a good eraser, because there are going to be some things you're going to want to make sure you erase. So let me jot down the formula for this piecewise function again. After I make the split at x equals 0, let's see. X equals 0 is right here. So I'm going to draw a little dotted line on the y-axis to remind me that that's the split point in the function's domain. For values of x that are less than or equal to 0, our graph is going to be generated by f of x equals 2x plus 5. So over here, I should see the graph of this function for x values that are less than or equal to 0. For x values that are greater than 0, if x is greater than 0, I should see f of x equals x minus 3 on the graph. So over here on this part of the domain, you're going to graph f of x equals x minus 3. Okay, so here's where the straight edge and the pencil really come in handy. The graph of this, again, this is a function, but it's linear. It's y equals mx plus b. So if you remember how to graph that from our earlier lesson on it, the y-intercept is at 5 and the slope is positive 2. So if I graph this line, has a y-intercept of 1, 2, 3, 4, 5, and then a slope of 2 means I can go down 2 and left 1, down 2, left 1, or I can go up 2 and over 1. So using my pencil, connecting those dots, I can see them. You may not be able to see them on the camera too well, but I can see them pretty well. So if I connect those dots, take your pencil and lightly sketch the graph connecting your dots. Okay, now I've already made a mistake. The mistake is right here because of the x equals 0 split. The only portion where I should see the graph of this is for x less than or equal to 0. So there should be no portion of this graph past my x equals 0 dividing line right there. So that means this part right here needs to be erased. That part of the line can't be there because that formula is not valid for that side of the x-axis. So for the portion I've got graphed, I do see the graph of f of x equals 2x minus 5 for x less than or equal to 0. So now I can come back and pen and complete my graph. Make sure I get all my points connected correctly. 2, 2, 2, 2, 2. Using my slope to try to make sure I get all the right points there. Okay, so this is the only place where I should see the graph of y equals 2x plus 5. 1, 2, 3, 4, 5. All right, now, one tiny little technicality. Earlier on some of the graphs, you saw breaks in the graph where one end would break with a closed circle and the other end would break with an open circle. Like this previous example we saw right here. Closed circle right there, open circle right there. Well, that kind of phenomenon happens with these piecewise functions too. Whenever you reach the end of this portion of the domain, because this portion has the equal to 0 part, since equal to 0 is there, then that means what occurs at x equals 0 does exist on this piece. So that means right here at the y value 5, I should see a closed dot right there indicating the end of this piece of the graph. Okay? So now what's going to happen is this piece is going to pick up where, on this part of the domain now that this other piece is done. Okay? So now I need to graph the function f of x equals x minus 3, also linear, has a slope of 1 and a y-intercept of negative 3. So if I were to graph that line, y-intercept negative 3, got my straight edge and my pencil back out, and a slope of 1, I'm going to go up 1 over 1, up 1 over 1. So you go at a 45-degree angle like this from that y-intercept. And so that would produce a line that looks something like this. But again, I've already screwed up. Okay? This piece only exists for x greater than, not equal to, but greater than 0. So that means over here where I've got it graphed for x less than 0, it's overlapping with the graph of this one. It's failing the vertical line test. So keep that eraser handy and erase that portion of the graph. Okay? And then what you want to do is realize that at x equals 0, this function technically doesn't exist yet because this one exists up here. So at the beginning of this piece's graph, you're going to need to deliberately draw an open circle indicating the fact that you're letting me know that you know what this inequality means. Equals 0 is not included with that part of the domain. So you can still use it as a starting point, but it has to be an open circle when it's paired with the greater than inequality and not the equal to part. So now that I see how this function picks up at that y value, I can connect the rest of the graph in ink and finish my graph. Know what that piecewise function properly looks like. Okay? So when graphing piecewise functions, you have to pay very, very careful attention to that dividing value. That dividing value tells you how the different pieces are actually going to come up to, and some will meet with a closed circle, some will meet with an open circle, but that just has to be that way because this is still a function that has an all real number domain and it still has to pass the vertical line test. So if you draw that vertical line through x equals 0, the vertical line hits here but doesn't hit here because that's a deliberately void, blank point. So this is a proper function, but that's characteristic of piecewise functions, is they just have gaps in their graph like that.